Hi everyone, this is the fourth and last video for section 7.3, multiplying and dividing decimals. So in this video, we're going to talk about scientific notation. So a decimal is written in what's called scientific notation when it looks like this. It's a number A times 10 to the n, where A is a number that's greater than or equal to 1 and less than 10, and n is just a whole number. That shouldn't say whole number. I'm sorry. This should say integer. So n needs to be an integer because we can't have the case where the decimal is negative. So this is supposed to be integer. Okay, so kind of how to think about this is we want it to be some number times the power of 10, whether that be a positive power or a negative power. And A only has value in the ones place. Or not only has value, but the largest place value of A is the ones place. And so that's what we mean when we say that A is greater than or equal to 1 and it's less than 10 means that it has to be bigger. Greater than or equal to 1 means it has a value in the ones place, and it being strictly less than 10 means that, well, the biggest value is in the ones place. We don't go to the tens place. So that's all it means. So scientific notation is really useful when you write a really large number or a really small number. You can express it in a compact way without writing a bunch of zeros in the decimal places or a bunch of zeros to represent lots of thousands or millions or anything like that. So you might have seen this before in some of your high school science classes or any of your college science classes if you've taken those already. This is just a really common way to write really large or small numbers. So we want to look at these two examples to see if they're written in scientific notation the correct way. So remember, the correct way really comes down to checking this value A that's multiplied by some power of 10. So in this case, we have 4.6 and 4.6. So these both are 4.6 times some other number, which is in correct scientific notation, right? The number that we multiply by the power of 10 has largest place value in the ones place. Well, 4.6 does. And so we want to talk about how to write this in expanded form, or I'm sorry, in standard form. So the standard form just means to expand it, right? So 4.6 times 10 to the 12. So you start by writing 4.6. And then if the exponent is positive, so if the exponent is positive, you move the decimal to the right. So you move the decimal to the right. That just represents every time you move the decimal, right? Because as we've talked about in section 7.1, each decimal, where the decimal is, changes your number by a factor of 10, right? So we can either have 1,000, 100, 10, 1, a tenth, 100th, 1,000th, and so on. So no matter where the decimal is, it changes the value of that number by a factor of 10. And that's why we have this standard form that multiplies by powers of 10. Moving the decimal to the right, like so, multiplies the number by that many powers of 10. And if we have a negative exponent, we move the decimal to the left, which represents dividing by 10. And that's all you do to write a number from scientific notation to standard form. So this is all explained in the textbook in chapter 7 on page 270 and 271. So make sure that if you haven't read that, you can go back and do that just so this will make a little bit more sense to you. Okay, so we want to do that. with these two. So we move the decimal to the right. In 5a, since it's a positive exponent, we're moving the decimal to the right. And we are moving the decimal to the right the amount of places that the power is of 10. And this is because, as just explained, moving the decimal multiplies or divides by factors of 10. So if we want to multiply it by 12 factors of 10, we move it 12 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's where our decimal point is now. And so every place that didn't have value before just gets filled in with zeros. So this number is 4, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. And I'm going to start putting commas in from the end of the number, right? Every 3 zeros or every 3 digits, you put a comma. So this is this really big number. Okay. And now we have in B, we have this negative exponent. So that means we're just going to move the decimal to the left and we're going to move it twice. So we're looking at 4.6, 1, 2 is all we do. We put our new decimal place. So this is 0.046, which is 46 thousandths. And that's all you do. So an example of a number that would not be in correct scientific notation is if we had 0.46 times 10 to the 13, this is incorrect form. And that's because the number that we're multiplying by a power of 10, 0.46, this does not have its largest place value in the ones place. The largest place value here that we have a non-zero value in is the tenths. So this is incorrect form because the number we multiply by a power of 10 doesn't have any value in the ones place. And another example of incorrect form is 46 times 10 to the 11th, right? This one is incorrect form because it has value in the tens place, and that's not what we need either. Okay, so these are incorrect forms. Okay, so now we want to look at converting numbers into scientific notation. So these two examples took a number in scientific notation and wrote it in standard form. We can also do the opposite. So we want to write these numbers in scientific notation. So one really common way that people tend to write scientific notation is with this uppercase E. So this E is what calculators typically say. If the answer that to an operation that you've plugged in a calculator is a really large number or a really small number, the calculator only has so many place values it can display on a screen. So if it's a really large number, they tend to write this E. And all that this means is this is 4 times 10 to the 17th is all that E is short for. So this is calculator notation. And although we don't use calculators in this course, it's good to know that if you allow students to use calculators in your classroom, what it will look like for them. Okay, and so now we're looking at this really long decimal. So we want to write this in scientific notation. So we want to find a number that has largest value in the ones place to represent this long decimal. So to do that, we can move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. And if we move the decimal 11 places, then we get 5.9, which is something that is in a correct scientific notation form because 5.9 has largest value in the ones place. And we move this 11 times. So this is going to be times 10 to the actually negative 11 instead of positive 11, because if we're starting with 5.9, we need to move the decimal place 11 times to the left to get this decimal, whereas in order to find out how to write this in scientific notation, we moved it to the right. So just kind of keep that straight in your head of essentially negative exponents are smaller numbers, right? And this is consistent with what we talked about when we went over exponents, that negative exponents are just smaller things in general. Okay, so now that we've talked about going back and forth between scientific notation and standard form, we can also do operations using scientific notation just to make it a little bit easier. So if we're looking at multiplying these two decimals that are really long and complicated, we can do this using scientific notation form rather than standard form to just make it a little bit easier for ourselves. So the first thing to do when you want to do this example 7a, if you want to use scientific notation, you need to convert both of the numbers into scientific notation. So we go 1, 2, 3, 4, 5, 6, 7. So this is 3.8 times 10 to the minus 7. And we want to multiply that by, we convert this one now, 1, 2, 3, 4, 5, 6, 7 again. So this is 4.5 times 10 to the negative 7. Okay, so if we want to multiply these two things together, how we can do that is we can pull out the 10 to the 7, right? This is, all of these things are just being multiplied together. So we could even take out these parentheses if we wanted to this. Just put a multiplication sign in here. And now we're looking at the product of these four factors. So we can use the commutative property and the associative property of multiplication to kind of reorder this. So this is 3.8, 3.8 times 4.5 times 10 to the negative 7 times 10 to the negative 7. And we do this because, well, we know how to combine these 10 to the negative 7s easily using our exponent rules because they have the same base of 10. So we move those to be together. So now we want to find out, we want to know this first product of 3.8 and 4.5. So remember that to multiply these things, we write them vertically, 3.8, 4.5, lining it on the right. And then we just multiply them like they were whole numbers. So 5 times 8 is 40, 3 times 5 is 15, plus 4 is 19. We add a placeholder. 4 times 8 is 32, carry the 3. 3 times 4 is 12, plus 3 is 15. So when we multiply these as if they were whole numbers, we get 1710. And remember that now we need to add how many decimal places there are. So there's 1 decimal place here, 1 decimal place here. So then we have 2 decimal places down here in our answer. So this is 17.10. So 17.10. And then next we multiply these 10s together. So 10 to the negative 7 times 10 to the negative 7. If we multiply numbers with the same base, we add the exponents. So this is 10 to the negative 14. And this is a correct answer. I say a correct answer because it is not the correct answer. So if we wanted to write this using scientific notation to write it in the proper form, we need to check that it's in the correct form. Because remember that a number in scientific notation, the largest number that you multiply up here in the front has to have the largest value in the ones place. So because this is 17, it does not satisfy that. So we need to rewrite it as 1.71. And then we need to change what we multiply it by. So now we moved our decimal place 1 to the left. And remember that whenever we move it to the left, normally the left is subtracting, but to rewrite this, you rewrite it as positive. So this is 10 to the negative 13. Also, you can think about it as if we're looking at 17.10 times 10 to the negative 14, we're moving that decimal 14 places to the left. Well, in order to rewrite this, we already moved it one to the left. So we need to move it one less to the left. So that's why we decrease from 14 to 13. Okay, so that's how we do this one. So now let's look at B. So B is looking at 6.25 times 10 to the 5th squared. So again, we can write this as 6.25 times 10 to the 5th, and then 6.25 times 10 to the 5th. And then we reassociate everything. So this is 6.25 times 6.25 times 10 to the 5th times 10 to the 5th. Okay, so now we need to multiply 6.25 and 6.25. Oh, this is going to be a lot of work. So 5 times 5 is 25. 5 times 2 is 10 is 12. We carry a 1, so then we get 3, 1. Add a placeholder. 25 times 2 is 50. 6 times 2 is 12. Add 2 placeholders. And then we get 6 times 5 is 30. So we have a 0, carry the 3. 2 times 6 is 12, plus 3 is 5, carry the 1. And then we get 37. So even though I said this was going to be a lot, I mean, it was a lot. However, you can do it. I know that it's annoying to not be able to use a calculator in this class. I am aware. However, that just is what it is. Okay, so now we add all these up. So we have 5, 2, 6, 0, carry the 1, 9, 3. Okay, so we have this. So now we had 2 decimal places here and 2 decimal places here. So that means that we're going to have 4 decimal places here. So we get 39.0625. So this is 39.0625 times 10. Remember, when we have the same base, we add the exponents. And then we need to change this one a little bit to make it in correct form. So we change this to 3.90625 times 10. And we moved it one to the left. So we need to move it one more to the right to counteract that. Okay, so this is how you can do computations in scientific notation. So there's more examples of this in the book. For example, there's a division example on page 271. You'll have to do division as well on your homework, so go check that one out. Yeah, we don't do a lot of like just computation like this in this class. But as you can see, even though these are really big and really small numbers, we can still do all of these computations without a calculator if we just use all of the algorithms and the tools that we have learned so far. So that's all for scientific notation. That's all for this section, and that's all for this video.